after last week's video, I'm going to do my best to make sure that there's no silliness involved whatsoever in these videos. Okay, so I'll do my best, and we're going to make sure that Mr. Finger doesn't come back. In this module, we're going to be dealing with more trigonometry and trigonomic functions. However, before we actually get into the real trigonometry, I do want to discuss some things with you concerning angles that especially is going to be really important when we go into the real meat and potatoes of trigonometry. So first off, I believe it was back in the first video of the geometry models, we were talking about angles, and I stated that the distance between an angle could be defined as either degrees or as radius, and that's true, but I do want to go over a little bit more detail on some things. So first off, I've lost my marker. There it is. I'm sorry, I am really trying to keep the silliness. Sorry. Actually, no, I'm not. I'll be silly in this video too. I lied in the first part of the video. I'm going to be silly. Just get over it. Alright, so one thing I do want to talk about is a few things. We're just going to terminology. So we have just a flat out angle, okay? Nothing all that bad. Okay? So we got an angle here. However, we can go in a lot more detail on it. What did I draw first? I actually drew this part right here first. Well, this is where my angle starts, and what we call this is the initial side. Okay? The initial side is simply the place where an angle starts. So, in your notes, just kind of know that this is my initial, and if that's not how I spell it, well, that's okay. I'll fix it in the video down here. This is the correct way how to spell it. Alright, so we have the initial side. We also know that if this is my starting point, my initial side, this is going to be my ending side, or more professionally, mathematically speaking, it's our terminal side. Not to be confused with the Walking Dead terminal. Some of y'all got that reference, some of you didn't. Alright, so we have an initial side and a terminal side. Alright, so generally, how do we measure this in degrees? There goes my top. We actually would put our protractor, and we would go from this part right here, and we would go up to this part, and we would measure it. So notice what I just did. I went this direction, okay? And what I found out is that this would be a positive angle. Alright? So it's a positive angle when I went that direction. Just like that. So let's just say I have, for the sake of argument, this is a 45-degree angle that I've created here. And this is how we normally measure angles, okay? However, sometimes we like to do things the hard way. This time I went a positive angle to got positive 45. But what if I didn't want to go positively? What if I wanted to do things backwards? Well, we can. This was my initial starting point. Here's my terminal, but I can go a different direction. I can actually go this direction. I'll do it with dots this time. Look at what I did. I went backwards. I went all the way around my arm to get to my thumb. Okay? So what did I really kind of create? Well, if you kind of notice here, even though it's a little jacked up, the positive angle and this other piece, this would be my negative angle. Okay, that's my negative angle. Well, how many degrees is it? Well, think this through. Notice what kind of shape we've got going on here. It's a circle. Well, if this is 45 degrees and this shape is like a circle, I could find the negative angle by subtracting. I could say 45 minus 360, and I find out that this negative angle that I have created is actually negative 315 degrees. So instead of going positively, which is this direction, I went negatively, which is this direction. And I still started at my initial, went all the way around the long way, and came to my terminal. Alright, this brings us to some more interesting concepts which we will call coterminal angles. Coterminal angles are simply this. They are angles that share the same initial side and terminal side. Alright, so what's happening here is that really we're going to discuss three types of coterminal angles. Really, in all truth and honesty, we can make an infinite amount of them if we wanted to, but we're going to discuss the first three. Well, let's do the very simple one first, okay? Let's just say we have an angle of, I don't know, let's say that this angle is 36 degrees, okay? So we have an angle of 36 degrees. It has two more coterminal angles that we're going to discuss. The first one is the easy one. We've already talked about it in the previous clip, and it's the negative coterminal. So what that is, it's instead of going the positive direction that we always go to measure these things, we're going to go the opposite direction in which we always go. So we're going to go this direction. And we're going to come back to it. And just like a while ago, we can take and find this angle by saying 36 degrees minus 360. Well, when we do, we can use our handy dandy calculator and we get that the negative angle is negative 324 degrees. Alright, so our negative angle that we went around the long way is negative 324 degrees. However, there's also another one. We could say positive angle. What? Wait a minute, this is a positive angle. The positive angle is 36. Yes, but there's more, okay? So our positive angle could happen like this. So here's my angle. I'm starting at this point and I'm going through. Normally we would stop at the terminal point, but because I just want to be a pain, I'm not just going to stop there. I'm going to go through it and I'm going to keep going around. I'm going to pass my initial point again, and guess where I'm going to stop at? I'm going to stop at my terminal. So what have I just created? I've created a really big angle. I started here, just kept going. I didn't want to stop there. I wasn't ready for it. Kept on going around, went back to where I started. I'm still going here because this is literally going all the way around your arm to get to your thumb. So what did we really do? Well, we know we went 36 degrees here because that's what we went first, but we kept on going, so we made an entire more circle. So really we can say 36 plus the 360, and what we get plus 360, and what we get is this, 396 degrees. Alright, so in your notes, the very first question is, what is the least positive angle and negative angle that is coterminal with 86 degrees? Well, look, here's 86 degrees, so you want to find the negative? You're simply going to say 86 minus 360. And when you do, you find out that you get negative 274. So that's your negative angle that you need. You need negative 274 degrees. That's going the long way around, okay? Well, now the next part is, what's the positive? Well, simply you would do 86 degrees plus 360 degrees is equal to 446 degrees. Alright, that's simple. So why don't you try the other one on your own? I think you get this concept. You're just basically subtracting 360 or adding 360. And I'll give you the answers. Alright, so in the problem you were asked to find the different coterminals of a negative 148 degrees. Well, to find the first one, you subtract. That gives you the negative, so you get negative 508. The next one, you add 360, so you would get positive 212 degrees. And that's pretty much it about coterminals. I mean, all you're doing is adding and subtracting 360 each time. Shouldn't be that hard. Alright. So all the way up until this point in time, we've been measuring angles in degrees. And that's all well and good. However, sometimes we need to be more exact. Like, we actually can break these down into what we call minutes and seconds. If that sounds familiar to you, it should. It should sound like time. And if you don't know what minutes and seconds are, please go back to kindergarten. Alright, so with that being said, it's really working on the same concept, where 1 hour is 60 minutes, or same thing with 1 degree is 60 minutes. Okay, you get the idea. So we can simply say this: 1 minute is equal to 1 degree divided by 60. Or basically we could say 1/60th of a degree. Alright? And then 1 second is really 1/60th of a minute. Alright, and so this should be pretty much review for you. I mean, this concept is not that hard because we use hours all the time, and so instead of hours we're going to say degrees. So we're going to use that same principle with what you know how to use time to work with degrees now. What we're actually getting ready to do is, like in the next example, I've given you 132.62 degrees. We want to express that into degrees and minutes. And it's actually going to be easier if we go to the .cam, and I'll show you how to do this with your calculator. Alright, so in this, it says express the following to the nearest minute. So we have 132.62 degrees. Well, here's the easy part. We already know what the degrees are, so we're going to just keep this guy, 132, and we're just going to keep that. So it's 132 degrees. So we know that automatically. Now, it's this next part that gets a little confusing. It says 0.62 degrees. Well, a while ago, I told you that 1 minute is 1/60th of a degree. So really, in order for me to find out what this is to the nearest minute, I'm going to simply take this decimal and I'm going to multiply it by 60. So I'm going to simply multiply it by 60. So when I do, I'm going to do that in my calculator. I'm going to say 0.62 times 60, and I get 37.2. So I can rewrite this as 132 degrees and 37.2, and then minutes. Alright, so minutes is simply just a little hash mark. And since it told me to do to the nearest minute, I can really just simply say 132 degrees and 37 minutes. And that's really all this is. Basically, you know what the decimal is, simply multiply it by 60 and you're going to get your minutes. Alright, so why don't you try this one on your own? For this one, you should have got negative 48 degrees and 19 minutes. In this next example, it says express the following to the nearest degrees, minutes, and seconds. So really we're going to do the same type of procedure. We know that this is going to be 30, so we're just going to go ahead and write 30 degrees. Alright, so we need to change this 0.24 into minutes. So we're going to say 0.24 times 60, and we get 14.4. So that's 14.4 minutes. Now, instead of rounding, we need to go a little farther and change it also into seconds. Well, just like we did a while ago, where since we knew that 1 minute is a 60th of a degree, we know that 1 second is a 60th of a minute. We're simply going to take this new decimal, which is 0.4, and multiply it by 60. So 0.4 times 60 gives me 24. So I have just found out that this is going to be 30 degrees, 14 minutes, and 24 seconds. And the way we denote seconds is with 2 little marks. So minutes has 1 and seconds has 2. Alright, so why don't you try the next one on your own? What you should have got was 53 degrees, 15 minutes, and 36 seconds. So in this it says convert the following angle to degree notation. And what we have is 65 degrees and 46 minutes. Alright, that's what we have right now. So what we're trying to do is to go from this all the way back to just degrees. Now I want you to look at the side. On the side of your notes, you can't see it on the camera, but you see it in your notes. It says do not round until the end, then round to 2 decimal places. So let me say that again. Do not round until the end, then round to 2 decimal places. Alright, so let's go ahead and do this first one. Well, since we're converting this all straight out into degrees, the easy part is this 65. Well, we know that 65 is going to be in our answer. So it's going to be 65 point something. So now we need to take this 46 minutes and find out how many, what's that going to be in decimals. All we really do is, before we were multiplying, now we're going to divide 46 divide by 60, and we get 0.76 infinity. So that's what we write, 0.76 infinity. And this thing told me to round off to 2 decimal places, so that's what we're going to do. 65.77 degrees. Alright, so in this problem we have 69 degrees, 12 minutes, and 17 seconds. And our job is to put this all into degrees. Alright, so like in the first problem where we just had minutes, we took the 46 and we divided by 60 to get our decimal. We're going to do something very similar with the seconds and the minutes. So let's just go ahead and do it. First off, we need to convert the seconds into minutes. And the way we do that is we're going to say 17 divided by 60. And that gives us this really long decimal, 0.283 infinity, infinity, infinity. Alright, now, a while ago I told you we never round until the very end. So this is the decimal of version of this 17 seconds. So what we're going to do is we're going to actually put plus 12. So 12 minutes and 17 seconds is actually 12.283 infinity minutes. Alright, so now that we know what that is, we can actually convert this all into degrees by dividing this by 60. And what we do is we get 0.20472 infinity. And we add that back to the original 69 degrees, and we actually get 69.20472 infinity. Now, what we can go from here is just round to the 2 decimal places. And this would give us 69.20 degrees. So what I actually want you to do now is I want you to try C and D on your own. Alright, so what you should have got for C was negative 38.58 degrees, and for D, negative 25.84 degrees. This problem states determine one positive and one negative coterminal angle for the angle given. If you remember back near the beginning of the video, we stated that in order to find coterminal angles, we're basically going to do for the positive coterminal angle, we're just going to add 360, and for the negative coterminal angle, we're going to just subtract 360. Now, in this particular problem, I've given you your angle in degrees and minutes. So we can do this, solve this problem several different ways, but I think this is probably, I don't know, one of the more simplistic ways of doing it, where you don't have to worry about concentrating on the various problems with how many minutes you're going to borrow from the degrees, etc., etc. The easiest way to do it is to go ahead and convert this whole thing straight out into degrees. Well, if we do 45 divided by 60, we get 0.75. So this angle is actually 20.775 degrees. Alright? Knowing this, we can simply find our positive angle by adding the two numbers, saying 360 plus the 20.75, and we get 380.75 degrees. And for our negative angle, we know that in order to do it, we have to subtract 360, and after we do the subtraction, we get negative 339.75 0.25 degrees. Now, this is good enough for at this point in time, but let's go ahead and put it back into minutes like we normally do. Alright, so 380.75 degrees. That's really saying 380 degrees, and we need to change that 0.75 by multiplying it by 60, and we get 45 minutes. Alright, so let's do our negative. We know we're going to keep the negative 339, so we got to change the 0.25 by multiplying it by 60, and we get 15 minutes. So, we get negative 339 degrees and 15 minutes for our negative angle. So, to reiterate, basically, change this all into a decimal of degrees, subtract and add as needed, and then change it back to your minutes. So try this one on your own. Alright, so for this problem, we're going to take the 40 degrees and 30 minutes, and we're going to convert it all into degree format. So it would become 40.5 degrees. Alright, from there we're just going to add the 360 to find our positive angle, and we get 400.5 degrees. We convert it back into minutes, and we get 400 degrees and 30 minutes. Alright, let's do the negative. We're going to do 40.5 degrees minus 360. We get negative 319.5 degrees. We convert this back into minutes. We get negative 319 degrees and 30 minutes. Alright. So, we've talked about degrees, and I've told you before that there's another way that we can measure angles, and it's called radians. So we can measure how many radians an angle has. And basically, our definition of a radian is this. A radian is the angle made when the radius is wrapped around the circle. So, you're probably saying, huh? Alright, so let's go back to some basic geometry. Alright, so in the center of my circle is what we call the center. Remember that? So we got the center of the circle. And from the center of my circle, get my handy dandy ruler here, all the way to the border of my circle, we know that this is my radius. Okay? So we know that that's to be my radius. Now, what if I was able to take the length of this radius and move it to the outside edge around the border? So what do I mean? Let's do this. I'm going to color this edge purple right here. So, this little piece that I've done, this little arc, this angle that I am coloring in right here, and let's see if I can find a highlighter. Let's actually highlight it since the purple didn't show up. So this highlighted region that I've got right here, there we go. Alright, it is actually the same length from the center of the circle to my border. This length is the same thing from this part right here all the way around. So this length, which is radius, is the same length on the outside. And what we actually call this is our radian. Okay? So the length of a circle that is exactly equal to the radius. That's what that means. Now, knowing this, we can actually do some mathematical magic, and we find out that x degrees is equal to x times pi over 180 radians. Okay? I'll explain to you what this all means in just a second. We also find out that x radians is equal to x times 180 over pi degrees. So what does this do, and how does this help us? What I've given you is I'm asking you 15 degrees is equal to how many radians, and so we need to do some conversions. So what I told you a while ago is that x degree is equal to x times pi, whatever. So let's go ahead and do this. I know what my degrees are, so I'm going to say 15 degrees is equal to, well, what was x? Well, it was 15, okay? So it's equal to 15 times pi over 180, and this is going to give us our radians. So when we do this, we actually get 15 pi over 180, and then when we simplify this, we get that we have pi over 12 radians. So what did we just do? We found out that 15 degrees is really pi over 12 radians. So let's try this one. I've given you radians, and your job is to change this into degrees. Alright, so let's use what we said. I said x radians is equal to x over 180 pi degrees, according to what I gave you up top. So we're going to plug that in. What was our radians? Well, we know that we have 9 pi over 5 radians, and that's going to be equal to 9 pi over 5 radians times 180 over x degrees. We work this out. Well, excuse me, that's not x, that needs to be a pi there, over 180 times pi degree. Okay? So we work this out. What happens? Well, our pi's cancel out. We multiply the 9 times the 180, and we divide that by 5, and we ultimately get 324 degrees. So 9 pi over 5 radians is equal to 324 degrees. So what I want you to do is I want you to pause the video, try B and D on your own, and then come back and I'll work it with you. Alright, so the first one I have negative 165, and our job is to find degrees. So let's do it. We know that we're going to have negative 165 degrees is equal to negative 165 times pi over 180 radians. Okay, let's work this all the way out. We know that that's going to give us negative 165 pi over 180 radians. We're going to simplify it now, so negative 165 divide by 180, and you should know how to do this with your, we can say math fraction just to make our life easier. We can actually say that this is negative 11 pi over 12, or simply negative 11 pi over 12 radians. Okay, now let's try the next one. I have negative 3 pi over 2 radians is equal to negative 3 pi over 2 times 180 over pi degrees. I'm running out of room, so I'm going to just put DEG. Alright, when I do, we're going to get that negative, that the pi's cancel out, and we say negative 3 times 180 divided by 2 gives me negative 270 degrees. So basically, when we're converting, if we could just kind of remember this basic idea, and this is probably a Mr. Lewis equation that we've come up with. If we know the amount of degrees, we just plug in whatever the degrees is in this form of our equation. And if we know however many radians, we just plug it into this equation. Alright, so let's move on. Alright, so in these four, it says basically we're converting degrees into radians again, but this time it says find final answer to the nearest hundredth. A while ago when we were doing it, we just kept it with pi. It was just easier to keep it that way. We didn't go out any farther. This time we're going to basically solve everything out. So let's just go ahead right straight to it. We already know that this is 34 degrees, and according to what I told you all ago, we know that we're going to say 34 times pi over 180 will give me my radians. Okay, so we know that right now off the bat. So let's go ahead and work this all the way out. we're going to say in our calculator 34 times pi divide by 180, and then it tells me to round to the nearest hundredth. So here's my 10th spot right here. There is my 100th spot, and that 3 tells that 9 to stay the same. All the numbers here become zeros and get dropped. So our final answer is going to be 0.59 radians. Alright, so let's try the next one. We have 5.697 radians, and we need to go into degrees. So we're going to use the little formula that we came up with. We know that we're going to take 5.697, and we're going to multiply that by 180 over pi, and that's going to give us our degrees. So let's do this with our calculator. We have 5.697. We're going to multiply that by 180. We're going to divide it by pi, and we get this. 326.414 blah blah blah. We round to the nearest hundredth. Here's my 10th spot. Here's my 100th. That 4 tells that 1 to stay the same. All these become zeros and get dropped. So our final answer is 326.41 degrees. Alright? So what I want you to do now is try F and H on your own and see how you did. Alright, so for these you should have got 0.89 radians, and for the next one, negative 196.64 degrees. Alright, sometimes we're asked to graph degrees or radians on a Cartesian plane, and when we're asked to do that, it asks us to graph it in what's called standard position. Alright? Standard position is simply this. The initial side of the angle that you're graphing is going to be located right here on the x-axis, right where I'm highlighting right now. So this would be where your initial side would be right there, and hopefully you can see that on screen. So it's basically going to go from the origin point all the way down positive x-axis. Alright, so that's where our initial side is. The terminal side could be anywhere. It can, depending on what our degree is. It can be in this section, going at this angle, like I'm kind of hand drawing here. It could be over here, it could be over here, and it could be over here. It really doesn't matter. All it does matter is that where you start at will always be at the origin point and through the x positive axis. That's the biggest part, is that this is where your initial side starts. Okay? Now, you're often asked basically what quadrant does it fall in, and how do you go about doing that. So go back to grade school. You should remember that this quadrant right here that we're in is actually our first quadrant, okay, designated by the Roman numeral. Alright, this next one will be here. This would be my second quadrant. This would be my third quadrant. And then lastly, this would be my fourth quadrant. So if I were to graph a line, excuse me, not a line, but an angle, and let's say, for the sake of argument, that it ended up in this area right here that I'm drawing, my terminal angle is in the first quadrant. However, if I drew a different angle and it ended up here, my terminal angle would be in the fourth quadrant. Alright, so that's really what we have going on. Now, here's some more things to kind of help you out. Alright, so since this is my initial starting point, my starting side, this measurement would be here 0 degrees. As it goes in a positive direction, this would be 90 degrees. This would become 180 degrees. This would become 270 degrees. And then as it comes back around to this part, we would get 360 degrees. Alright, so that's if it's going in a positive direction. However, we might go in a negative direction. And to kind of show this, I'm going to do this in a different color. So a while ago we started in a positive direction. Let's go in a negative direction. Again, our initial side starts here, so as this would be 0, down here would technically be negative 90. This would be negative 180. This would be negative 270. And then this would be also negative 360. This is only if we're going in a negative direction. So depending on what we're doing, and I'm going to slide this up so you can see everything. So if we go in a positive direction, it could go 0 to 90 to 180 to 270 to 360. But if we're going a negative direction, it's going from 0, negative 90, negative 180, negative 270, negative 360. So let's go ahead and start working on some graphs and seeing how this stuff really plays out. Alright, so this first one, it says graph the following angles in standard position. State the quadrant in which the terminal sides lie or as quadrant angles. Alright, so we'll talk about quadrant angles a little bit later. Alright, so this thing says that we need to go, and I'll slide this over a little bit more so you can see it. It says that we need to go 76 degrees. Well, our initial side is going to be right here, like I said, it's going to be right here, and so we know it's going to be on this x-axis. Alright, now it says go up 70 degrees. Well, I could get a protractor if I want to and actually measure 76 degrees, but I don't want to. I want you to go back to what I said. If we were going in a positive direction, we know that this would be 0 and this next piece up here would be 90. So do I need to go any farther? No. I should know that this 76 degrees is going to be somewhere in this quadrant. So I'm just going to kind of take a guess. I'm going to say that my angle might look something like this. Alright? And right now, for all intents and purposes, this doesn't have to be exact. So what did we find out? We know that negative 76 falls in the first quadrant. Okay? And I'm just going to put quad. So it's in the first quadrant. Alright, so now let's go look at the next one. It says negative 345 degrees. So what's happening here? Whereas in this first one I was getting a positive angle, I was going positively 76 degrees. This time I've got to go negatively. So I'm going to be going backwards. So remember what I said. This was 0, and since I'm going backwards, this is going to be negative 90. This is going to be negative 270 on this side, and this is, excuse me, not 270, but negative 180. And this up here is going to be negative 270. So as I go around, negative 345 degrees will not fit within this quadrant because this is only going from 0 to negative 90. And then this one will only goes from negative 90 to 180, so it won't fit there. This one goes from negative 180 to negative 270, so that's not good enough. And now we have this last one, where this becomes negative 360. Does it fall within this quadrant? Yes. And so I'm going to take another little guess, and I'm going to assume that it's approximately looks like this. So I actually started with my initial side here, and I went around this direction, and I stopped right there. And this is negative 345 degrees. Well, isn't it interesting that this, just like my first problem, also is in my first quadrant. So, just because it says a negative doesn't mean you're not going to end up in the same quadrant or a different quadrant. It doesn't really matter. You just follow what this tells you, and it can be any four. It doesn't matter whether it's a positive or negative. It just matters where you stop. Alright, so let's look on to the next one. So in this problem, I'm giving you the measurement and radians. So what do we need to do here? Well, the problem is everything I've given you is in degrees. We could do some other stuff, and I could tell you that all the radians and blah, 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 but I'm not going to do that. What we're simply going to do is we're going to convert 4 radians and find out how many degrees that is. Well, if you go back to remember what we discussed before, we can use that little handy-dandy equation, and we can say 4 times 180 over pi will give us the degrees we need. Alright, so when we do, we're going to say 4 times 180 divide by pi, and we get, and we're going to round to the nearest degree this time, we're going to get 229 degrees. Alright, so what we need to do is go in a positive direction, 229 degrees. So, we're going to do our initial side here, and we're going to go around. We need to go to 229 degrees. So we go around, this makes 90 degrees, this right here makes 180, this right here makes 270. So our angle is going to be somewhere in this vicinity. I'm going to make an educated guess again. I'll say, I don't know, let's just make an educated guess, something like that. That's probably wrong, but what we learn is that 4 radians is actually in the 1, 2, 3rd quadrant. Alright, so our answer is in the 3rd quadrant. So let's look at the next one, -5 radians. Well, we do the same thing again. We're going to convert this in degrees by saying -5 times 180 over pi. So what happens? We get -5 times 180, divide that by pi, and we get negative, we'll round to the nearest whole again, negative 286 degrees. Alright, so let's go ahead and do it. Since we're going in a negative direction, we're going to start here on our initial side, and we're going to go around. So this would be negative 90. This is going to give us from here to here, that's negative 180. From here to here gives us negative 270. And then all the way down is back to negative 230, gives us negative 360. So it's going to be somewhere in this quadrant, and I'm just going to take another educated guess and say that my angle is approximately, looks like this. Don't know if that's for sure or not. So we've gone from all the way around to this angle, and that should give us our negative 286. That means that our terminating angle is in our 1st quadrant. So what I'm going to ask you to do now is I want you to try the remaining 4 on this, and we're going to go and see how you did. So in this first one we have 284 degrees. So we start with our initial side and we keep going around until we get to our terminal angle, which is 284 degrees, and it's going to be in our 4th quadrant. Alright, our next one, we go with negative 219 degrees. We start with our initial side and we go back until we stop at our terminal angle, which happens to be in our 2nd quadrant. This one we have -3 radians. We convert that back into degrees to the nearest degree, which is about approximately 100 and -72. So we start with our initial side and we go back negative 172 degrees, and we end up in the 3rd quadrant. The last one, we have 2 radians. Change that into degrees, which is approximately 115. We start at our initial side, we go around until we get to 115 degrees, which is here, our terminal angle, and we find out that's in my 2nd quadrant. Well, I think we're going to end the video at that. I think what we're going to end up doing is just showing some, I don't know, Walking Dead clips, because I want to see the new season of Walking Dead. I have yet to see season 6. Season 4 and 5 were some of my favorite scenes, especially Carol. I just love that character. But anyway, for those of you who have seen the new season, please, 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 please don't give me any spoilers. Okay, see you next time.